this is Calculus 12, Chapter 3.9. This is the extra part where we're going to be going over exponentials and logarithmic functions. So, exponential functions look like powers, but the major difference is the variable is in the exponent rather than the base. And the base must be a positive constant. Okay, so for instance, y equals a to the power of x. So our variable x is in the exponent, a is going to be a positive constant, so a greater than 0. The domain for exponential functions is all reals. The range for an untransformed exponential function is y is greater than 0. So if we have a vertical shift, this will change. Untransformed exponential functions are always increasing. Transformed exponential functions can be decreasing. So this means there's a horizontal flip. So if it's increasing like this, if we horizontally flip it, it's going to look like that. The logarithm of a number is an exponent. So if we have log b of c, we're finding the power to which b is raised to get c. That's complicated, but once you see it, it'll be more obvious. The base of the logarithm is the same base of the power. So when we have log b of c equals a, that means c equals b to the power of a. Okay, so a is the exponent of b to get c. And we have to have conditions. B has to be greater than 0. B does not equal 1. And c is greater than 0. Okay, exponentials and logarithms are inverses of each other. So all these numbers should appear in both forms. So if we have a 64, that's the value or number that goes in here. This is the base, it goes down here. This is the exponent, it goes on the other side. Okay, we have log laws, we have exponent laws. I'm just going to remind you of some exponent laws. A to the power of m plus n equals a to the power of m times a to the power of n. And you probably haven't seen this one before. Change of base for exponentials. So a to the power of x equals b to the power of log b of a to the power of x. Okay, so these two are inverses, so they cancel out, and we're left with a to the power of x. We use another log law, which I haven't covered yet. We can rewrite this as b. This x comes out front because it's the exponent, log b of a. Okay, so you'll see these two being used in our proofs of derivatives. Okay, so 2 to the power of 4 times 2 to the power of 5 is 2 to the power of 9. So we're adding exponents. If we add logs, this is going to be log 2 to the power of 9. If we're just adding log of values, this is log 4 times 8, which is log 32. Okay, so 4 times 8 equals 32. Log of 4 times 8 is log of 32. And this is the general rule. Log a of x plus log a of y equals log a of x times y. And similarly for subtraction, that means division for powers. So 3 to the power of 7 divided by 3 to the power of 4, we subtract the exponents, 3 to the power of 3. So log 3 to the power of 7 minus log 3 to the power of 4 is log 3 to the power of 3. And if we don't have powers and we just have numbers, 28 divided by 7 equals 4. So log 28 minus log 7 is log 4. And again, we have the general rule, log a of x minus log a of y is log a of x divided by y. And powers of powers. 5 to the power of 2 raised to the power of 4 is 5 to the power of 4 times 2, that's 8. So log 5 to the power of 8 is 8 log 5. This is 3 log 6. Okay, so if we have an exponent, we can just bring it out in front of the log because we multiply exponents. Since log 6 is an exponent, we can multiply that by 3. So the general rule is log a of x to the power of k is k times log a of x. So we'll be using this one to do our proofs as well. And some other log properties. Log a of 1, that's always 0. Log a of a is 1. Log a of a to the power of b is b. And change of base. So this one's important as well. So log b of a, if we're changing it to log base c, we do log c of a divided by log c of b. And to convert it just to a common base, log a over log b. So if your calculator doesn't have a base function, you can just do log a divided by log b. And one last thing, we're going to be doing natural log, and that is ln x. And this is equal to log base e of x. Okay, we use base e frequently, so we have its own notation for log base e. And we pronounce it ln. And that completes this review.